All right, so section 3.6. Once again, we are extending our discussion on writing two-column proofs. This time, we are diving into angle proofs. Now, if you remember, there were a couple definitions that we need to keep in mind when we're writing angle proofs. Those definitions are the definition of an angle bisector, the angle addition postulate, and then what it means for two angles to be complementary and also supplementary. All right, so let's get into number one. So number one, I am given that angle AXC, which we can see is this big angle over here, is equal to the measure of angle DYF, which is this other big angle right here. And we're also given that the measure of angle 1, this little part of this angle, is equal to the measure of angle 3, this little part of this angle, okay? So over here, and we're asked to prove that the measure of angle 2, so the bigger part of this angle, is equal to the measure of angle 4, the bigger part of this angle. So writing our proof, we are once again given the statements, and we are asked to fill in the reasons, okay? So statement A, measure of angle AXC is equal to the measure of angle DYF, and also the measure of angle 1 is equal to the measure of angle 3. That is our given statement, okay? We see that up here. It was following the word given. This is what we were given to start with. Okay, so the next thing we're given is the measure of angle AXC is equal to the measure of angle 1 plus the measure of angle 2. And also the measure of angle DYF is equal to the measure of angle 3 plus the measure of angle 4. So we can tell right here that that is using the angle addition postulate, okay? So the angle addition postulate says that if I've got some big angle, so for this one, AXC, and I split that angle into two smaller angles, so angle 1 and angle 2, then the measure of the two smaller angles will equal the measure of the big angle. Okay, so that's going to be using the angle addition postulate, or we can abbreviate it as the AAP. And the same thing is true for angle DYF. It is broken into angles 3 and 4, so the measure of these two angles will equal the measure of the whole. So that is us using angle addition postulate. So now we move on to statement C. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. So if we recall back at statement A, the first one is the measure of angle AXC is equal to the measure of angle DYF. And then we see right here at stage B that we expand our definitions of those angles right here, AXC being the measure of angle 1 plus 2, and DYF being the measure of angle 3 plus the measure of angle 4. So to get statement C, they basically rewrote the first part of statement A, and then using what we learned at stage B, and that's how we got stage C. So they substituted in the values for measure of AXC and measure of DYF right here. And so that was going to be using the substitution property. Okay, now to go to D. So at D, we're given the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 4. So recall again back at stage A. The second part was the measure of angle 1 is equal to the measure of angle 3. And if we notice from C to D, the only difference in these two statements is that this measure of angle 3 became measure of angle 1. So by using the substitution property, we were able to substitute out measure of angle 3 for measure of angle 1 because we saw up here that they're equal. And so if they're equal, we can switch them out whenever we want to. So lastly, to get from D to E, we notice that the measure of angle 1s are missing from both sides, so we know we had to get rid of them somehow. So I had to subtract the measure of angle 1 from both sides of my equation to get my final statement. My proof statement, which is up here, so we knew that's what we were ending on, is measure of angle 2 is equal to the measure of angle 4.